first is what happens when we have imaginary zeros. So you're going to want to write this down. The conjugate zeros theorem tells us if you have a polynomial with only real coefficients, so when you're looking at it, there are no i's in it, then if one imaginary number is a zero, so you have an imaginary number that divides it evenly, the conjugate of that number will also work. So those imaginary zeros are going to come in pairs. If one works, so does the conjugate. What this means. First thing we're going to do is write a polynomial that meets these requirements. So I need it to have zeros of positive 3 and 4 plus I. But we know that if 4 plus I is a 0, what else has to be? The conjugate, and all the conjugate does is change the sign in the middle. So 4 minus I would also have to be. That is not true for real numbers. If 3 is a 0, that's fine. Doesn't tell us anything else. It's just the imaginary numbers have to come in pairs. So when we write the polynomial, it's x minus each of these things. So first would be x minus 3. Second term, if you do x minus 4 plus I, that gives us x minus 4 minus I. And we have to do x minus the 4 minus I, so x minus 4 plus I. Again, the only difference on those two is going to be the sign on the I. We could multiply this all out and see how the i's disappear, but I don't really want to do that. I just want to leave it in factored form. So we had to recognize we needed one more 0, and then we did our polynomial by putting the factors. So this one, I'm going to tell you that negative 2, positive 5i, negative 1, minus I are all zeros. So I've given you 3 of them so far. But anytime you have an imaginary, you also have its conjugate. So if 5i is a 0, what else has to be? Negative 5i. If negative 1 minus I is a 0, what else has to be? So how many total parentheses am I going to have? 5. So if negative 2 is a 0, what's my factor? If 5i is a 0. If negative 5i is a 0, then it's x plus 5i. Okay, negative 1 minus I.
X minus 1 minus I.
Yeah, so you would have to distribute that negative. So it becomes x plus 1 plus I. And if negative 1 plus I is a 0, if you distribute your negative, you get x plus 1 minus I. So far, so good? Let's do a couple more writing polynomials, but I'm going to change this a bit. So I'm going to tell you that my zeros are negative 3, negative 2, and 5. So do I have to add anything else to the list? No, because there's no imaginary zeros. If negative 3 is a 0, what goes in my factored form? If negative 2 is a 0. So we've met that requirement. Then I gave you something different. I said f of negative 1 equals 6. That means when I plug in negative 1 for all my x's, I have to get 6 for my answer. We can't have any other zeros, but what we could possibly have is some number out in front of all of this. So I could have like some coefficient here. We need to figure out what that is. So I'm going to plug in my negative 1. Negative 1 plus 3, 2. Negative 1 plus 2. Negative 1 minus 5. When I do that, this whole thing should equal 6. So 2 times 1 times negative 6 is negative 12. We divide. We find out that number has to be a negative 1/2. So my final polynomial that meets all of these requirements is negative 1/2 times x plus 3 times x plus 2 times x minus 5. So I didn't have any imaginary zeros there, but I did give you enough information to find your coefficient. One more look at that. So 4 is a 0. What do we have to add? The multiplicity is 3. What does a multiplicity change? We talked about multiplicities a little bit in section 4.1 when we were talking about what it did to a graph. When we said that multiplicity was how many times it was a 0, it was like the exponent. So if the multiplicity is 3, that means it has a cube on that. Then I've given you some information. F of 2 equals negative 24. So we have to figure out what this number is in front. So if I plug in a 2, 2 minus 4 is negative 2 to the third equals negative 24. Negative 2 to the third is negative 8. If we divide by negative 8, we get 3. So my polynomial is 3 times x minus 4 to the third. Any questions there? I plugged in 2 for my x, so 2 minus 4. Alright. Can I do one last quick example, then I'm done? One, two, three. This. So I gave you an equation in factored form, and I want zeros and multiplicities. If it's already factored, you guys were finding zeros on your quiz, and all you have to do is set each parenthesis equal to 0, so that's really the same thing here. Out front we have 3x, so if you set 3x equal to 0, you get 0, so that's my first one. 4x minus 5, if I set that equal to 0, you get 5/4. Since it had a cube, what does that mean? It's a repeated solution, so it's a multiplicity of 3, so we just put M3. Alright. X squared plus 3. What multiplicity will this one have? 5, because of that exponent, okay? So if I subtract my 3, what do we have to do?
Square root.
And when you add a square root, you do plus and minus. What's the square root of negative 3?
I square root.
So that means you have I radical 3 with a multiplicity of 5 and negative I radical 3 with a multiplicity of 5. You could have also written it as plus and minus. I just separated them to really emphasize that they are two different zeros. So, we'll pick up here tomorrow. No homework or anything, I just want to